next step for dehydration of aldol product. Okay, so this is for dehydration of aldol product, which is aldol reaction mixture is heated in base or acid. So dehydration to an alpha beta unsaturated carbonyl compound. So this one is alpha hydroxyketone or aldehyde from the previous aldol product process. So dehydration is favorable because the product is stabilized by conjugation of the alkene with the carbonyl group. So we want to stabilize this pi bond or alkene with the carbonyl group. So here is the alpha carbon because next to the C double bond O. So next to the alpha carbon is beta carbon, which is contained of a functional group OH. Okay, so this one we call as beta hydroxyketone because of OH, beta hydroxyketone or aldehyde. So the presence of acidic. Okay, so using the condition of heat or reflux, so product is stabilized by conjugation of alkene. So from here OH, okay, means by dehydration is we want to eliminate water to form a pi bond or double bond here, C double bond C, and side water as side product is water. So alpha carbon attached with the alpha hydrogen. So this alpha hydrogen is very acidic because of the between of carbonyl and also between of COH. So all hydrogen, alpha hydrogen, the middle of this functional group is very acidic. So the presence of water together with heat. So we want to adjust this product to the end product more stable by conjugated of enone to get this product. So some aldol reaction, okay, aldol product cannot be isolated because of rapidly dehydrated to alpha beta unsaturated compound. For this one, there are two of the aldehyde, okay, by using base. Okay, here the product appear, but this product or this intermediate cannot be isolated. Okay, the reason is because of dehydrated to alpha beta unsaturated compound. Okay, so we heat. So what happened? We get the alpha beta unsaturated aldehyde here. Okay, C double bond O. So this one is alpha, this one is beta. So form the alpha beta alkene here. So here is some of example. Okay, you want to react to form the aldol product, it must be aldehyde react with aldehyde, and then the presence of base here. So because of base, so we get the aldehyde plus alcohol aldol, or we call as beta hydroxyketone or aldehyde. Okay, for this one we call as beta hydroxy aldehyde. Okay, beta hydroxy aldehyde because C double bond O, the next of C double bond is hydrogen, so we call as aldehyde. Okay, continue, this reaction is continue by the presence of base and we heat. So here is the product of aldol. Okay, the process is aldol reaction. Continue this product aldol by dehydration. So we get the alpha beta unsaturated. Okay, we get the product alpha beta unsaturated by conjugated of enone. Okay, conjugated of enone. So we get this product. Okay, seems to this example. Okay, so now look at the mechanism of dehydration of aldol product. Okay, this is a general of mechanism for dehydration. The previously is mechanism for aldol reaction. So here we have the alpha carbon, beta carbon. So this one is C double bond O, which is a carbonyl. Okay, next to the alpha carbon, and next to the alpha carbon is beta carbon. Okay, so we have a base here. Okay, so base here and condition heat. Okay, so from this, what happened? This base, okay, abstract this proton, so produce water, because terms of dehydration means that we want to remove water. So after this proton detached from this carbon, so what happened? Electron move to the here, okay, between alpha carbon and alpha carbon and beta carbon to form pi bond here. Once electron move here, so become pi bond carbon, which is C double bond C. It cannot be C double bond C carbonyl. Okay, must be between alpha and beta carbon. So form pi bond, and this one electron move to the O. Okay, move to the O, so you can move to the O to left from this beta carbon. Okay, so here is a very acidic hydrogen, so that's why the base accept proton from here, because this proton is a very acidic. Okay, here, so you get the end product alkene C double bond C, because we want to stabilize the product by conjugated enon. This one, conjugated enon, so we get the end product of alkene and C double bond O. So we call as alpha beta unsaturated. Okay, side product is water, of course, because of this one is mechanism for dehydration, and side product OH minus. Okay, this one is mechanism for dehydration. So what is the driving for the equilibrium? So removal of water. In dehydration, must be remove of water. Okay, can be used to drive the reaction towards product. After dehydration, alpha beta unsaturated aldehyde or ketone are stabilized by resonance. Okay, so here we want to stabilize the end product by conjugated enon, and after that, when you get the dehydration, okay, so alpha beta unsaturated aldehyde or ketone are stabilized. So if the initial aldol fibers reactant, okay, subsequent dehydration step push the reaction to completion. Okay, it's mean by cyclohexanone, okay, using the strong base in ethanol solvent, so you get the aldol product. Okay, after aldol product, so what happened? Dehydrate. So this one is dehydrate to form the elimination process. So all of this, if you get the aldol product, if you get the dehydration product, so all this step we call as the aldol condensation. So next is synthetic application. Okay, so desired molecule beta hydroxycarbonyl, okay, beta hydroxycarbonyl or conjugated enon. Okay, conjugated enon. This one is aldol product, this one is for dehydration product. Okay, so all of these are product from the aldol reactant. Okay, so this subtopic we want to discuss how to prepare the starting material from the end product. Okay, so the end product must be ketone react with aldehyde. Okay, for this case, okay, look at here. Okay, you have the end product, alpha, beta, unsaturated aldehyde. Is a very important part because always ask in test, quiz, or final. Okay, this one your end product. Okay, alpha, beta, unsaturated aldehyde. This one is dehydrated product. Okay, so by dehydrogenation, by hydrogenation, so you can get the aldehyde. Okay, you can get the aldehyde by using the hydrogenation. Okay, from here we reduce this C double bond O to get the aliphatic of alcohol. Okay, this is why you hydrogenation to get the aldehyde. Okay, to get the aldehyde. And then for this one, hydrogenation at high pressure, so you get the saturated alcohol. So this one we call allylic alcohol because of contain of C double bond C. So this one you're using the hydrogenation at high pressure, so you get the saturated alcohol single bond. Okay, look at here. This one is aldol product. Aldol product. So if you're using the reduction, so you get the alcohol. Okay, so C double bond O reduced to form alcohol. So this one from the aldol, and then using acid and water. Okay, by using acid water, you get the alpha, beta, and saturated aldehyde. So this one, okay, from the two, must be from the two aldehyde, so you get the aldol product. Once you get the aldol product, continue the reaction, you get the continue reaction by reduction, you get the alcohol product. Okay, so continue from the aldol. This one is elimination, okay, or we call it as dehydration. So you get the alpha, beta, unsaturated. Okay, from here you reduce C double bond O, so you get the allylic alcohol. So this one hydrogenation, so you get the saturated alcohol. So from here you continue hydrogenation, you get the aldehyde. Okay, look at here. Okay, even though the reaction are same, but the difference of catalyst we use, so the end product is different. So extending the synthesis. Okay, saturated ketone might be prepared by catalytic hydrogenation of the inert product. Okay, this one is alcohol. Okay, here is ethyl hexanal. Okay, this one is aldehyde. This one is alcohol. Okay, starting from the aldehyde. Okay, because extending the synthesis is mean we want to explore the synthesis route here. Okay, so this one is the aldehyde. Okay, by using the strong base in solvent alcohol, you get the, here is the product aldol. Here you can get, at the end you can get the product of alpha, beta, and saturated here. And after that continue for hydrogenation, so you get aldehyde. Okay, by using platinum. Okay, by using platinum here. Okay, you get the, okay, platinum here, so you get the aldehyde. From this aldehyde continue hydrogenation, so you get the alcohol. Okay, so this one is exercise for your understanding. Okay, so next is cross Aldol condensation. Okay, there are two different carbonyl compound have alpha hydrogen, so cannot control the donor and acceptor. Okay, so here we call as cross Aldol condensation. we have a ketone, we have two types of aldehyde, the different of aldehyde. Okay, so aldol product, this one is aldol product. Okay, so you get a mixture of aldol product because of we using the difference of aldehyde. Okay, so this one is alpha beta. Okay, because this one and this one is product for this aldehyde. Okay, so this one is 2 molecule of acetaldehyde. We call this one for cross Aldol condensation, so you can get a mixture of the aldol product. Because we're using the different of aldehyde, first product must be between these 2 molecule of acetaldehyde. Number 2 end product here is from 2 molecule propanol. Okay, next is product between 2 molecule acetaldehyde and also propanol. Okay, so here is the another product, okay, between this one and this one. Okay, one of the carbonyl partner does not contain alpha hydrogen. One of the carbonyl partner does not contain alpha hydrogen, and the carbonyl is unhindered, such as benzaldehyde and formaldehyde. Okay, benzaldehyde and formaldehyde good electrophile and can react with enolate, mixed aldol reaction, successful. Okay, so this one is the important part, or this one is clue for the cross aldol reaction. Okay, so we have the benzaldehyde here, and we have the unhindered carbonyl. Okay, unhindered carbonyl, alpha hydrogen, only one R, so that's why we call this one unhindered. Okay, this one also unhindered. There are less of alkyl attached near to the C double bond O, so this one is a good electrophile. Okay, once good electrophile, so this one is alpha hydrogen, alpha carbon, alpha hydrogen. So this one is become donor, and this one is become acceptor, because acceptor is more unhindered. There are no alkyl group. Okay, so ketone, this one is aldehyde. So your end product should be alpha, beta, and saturated. Okay, because the aldol reaction occur here, alpha carbon. Okay, one cross aldol reaction give one predictable product, so only one product you can get. One of the reaction partner has no alpha hydrogen. Okay, so here have alpha hydrogen, so here is no alpha hydrogen. Okay, so the partner which there are no alpha hydrogen we call as acceptor. Okay, the other one partner we call as donor, because the carbon contain of alpha hydrogen. Okay, look at here, no alpha hydrogen, one product can produce. Okay, in basic solution, carbonyl with 1 or 2 alpha hydrogen is added slowly. Okay, this one is without hydrogen. Carbonyl without hydrogen put in basic solution, so what happens? Carbonyl with 1 or 2 alpha hydrogen is added slowly. Okay, dehydration occur immediately, especially extended conjugated system result. Okay, so this one some of example. Okay, this reactant, okay, no alpha hydrogen, because C double bond attached on the aromatic. Okay, so there are no alpha hydrogen. So this one reactant have alpha hydrogen. Okay, alpha hydrogen. Okay, alpha hydrogen. This one is alpha hydrogen. So end product, okay, this one you get one product because of contain of, because the partner no alpha hydrogen. Okay, so no alpha hydrogen, so it's become alpha beta unsaturated. This one is alpha beta unsaturated. Okay, for this one, okay, so this one is alpha carbon, and this one no alpha hydrogen, so you get the product of aldol product. Okay, because we're using a mile of base. Okay, this one is cross aldol ratio with acidic carbonyl compound. Okay, so ethyl acetoacetate completely converted into its enolate ion under less basic condition than monocarbonyl partner. So this one is aldol condensation with ethyl acetoacetate occur preferentially to give mixed product. So this one is a ketone. Okay, ketone as the acceptor. Okay, because of, if we look here, okay, so this one is acceptor and this one is donor. Okay, because of the structure have a 2 carbonyl. Okay, aldol ratio with acidic. So here's alpha hydrogen is very acidic. By using a strong base in ethanol, so you get the alpha beta unsaturated between the carbonyl. Okay, this one for cross aldol reaction in condition acidic. Okay, this one condition is only one alpha hydrogen, the other one is no alpha hydrogen. Okay, so this is focused on the acidic carbonyl compound. So carbonyl, okay, between of this carbonyl form alpha hydrogen. Okay, it's very acidic, so this one will give the aldol product. And the last, okay, and last is Claisen-Schmidt reaction. For cross aldol reaction with one partner is ketone. Okay, we call as Claisen. Product of ketone self-condensation is not obtained because equilibrium is not favorable. Okay, here is a ketone, here is aldehyde. Okay, so by using a base and condition heat, so you get the alpha beta. Okay, alpha beta unsaturated for ketone. Okay, so this one also you get the alpha beta unsaturated ketone. Okay, this one only for ketone. Okay, it's mean cross aldol reaction, okay, between aldehyde and ketone, so you get the ketone product. Okay, ketone product in unsaturated C. So here is an important part for mechanism Claisen-Schmidt reaction. Okay, first is what happened. So this is the ketone. Okay, base abstract this proton, so electron move to here to become C minus. Okay, base hydroxide remove proton, okay, from the alpha carbon. So one molecule of the ketone to give resonance stabilize, so form enolate and ion C minus. Okay, negative minus here, move here to become C double bond C, and this one electron move to the O, so become O minus. This one is intermediate in enolate and ion. Side product water. This is for step 1. Step 2, okay, so this enolate and ion, okay, attack this carbon. This one is step for the nucleophilic substitution mechanism. So nucleophile attack this electrophilic, so electron move to the O minus, so it's become the intermediate of alkoxide anion. Okay, this one is step 3. So alkoxide anion now negative charge. Okay, remove a proton from another molecule water. Okay, this means abstract proton. Okay, abstract proton to become the aldol product. Okay, here you get the beta hydroxy ketone. Okay, and subproduct OH. Step 4. So this beta hydroxy ketone is not stable, so we want to stabilize this product. Okay, by using the base, presence of base, abstract this proton to give side product water. This one is process of dehydration. Okay, so what happened? So this, okay, electron move to here, C double bond C. So we want to conjugate the anion, so jump to here, electron from here move here to become C double bond C, and this one will left. Okay, this part we call conjugated product in dehydration process. So you get the end product of dehydrated in alkene, alpha beta saturated. Okay, so this one is exercise you can to do for understanding. Okay, so lastly is cyclization via aldol condensation. Okay, cyclization is intramolecular dicarbonyl compound to form 5 or 6 member ring. Rings smaller or larger than 5 or 6 member are not favored. So here only focus for 5 or 6 member only. Aldehyde carbonyl carbon is attacked preferentially because aldehyde is less sterically hindered, more electrophilic compared to the ketone. Because ketone they have 2 alkyl attached on the C double bond O, but aldehyde there are only 1 R group attached on C double bond O. Okay, so here is there are 2 of carbonyl. Okay, by using strong base, so we want to cyclize intramolecular. Okay, intramolecular to form alpha beta, and side water is product. Okay, for this one, okay, here 1, 2, 3, 4, 5, 6. 6 carbon to form cyclopenta. Okay, so this one 1, 2, 3, 4, 5, 6, 7 to form 6 cyclo. Okay, okay, cyclohexanon. So this one cyclopentanone. Okay, look at here, if the 2 dicarbonyl and the chains is C6, C6, so product is cyclopentane. For 7 carbon, the product is cyclohexanon. So here is the mechanism. Okay, how to do the cyclize, how to cyclize this dicarbonyl. Okay, we have a dicarbonyl. Okay, this one. Okay, and this one. So what happened? There are 2 paths. Okay, for path A, which is this one. Okay, path A using a strong base. Okay, this one alpha carbon. Okay, will attack to this one. Okay, cyclize here. Okay, once you cyclize, so there are 2 alpha hydrogen. Okay, by using base, so base abstract this proton. Okay, remove this proton. Once you remove, so this one is become pi bond. Okay, and this one become OH. So you get here. Okay, this one is aldol product. Continue dehydration, so you form alpha, beta, and saturated. So for path B, Okay, if this one okay, this one is okay, this for this one alpha hydrogen. Okay, you cyclize, okay, cyclize with this one, so it form the cyclopropane, so it's not occur. Okay, this path is not suitable for the cyclized aldol reaction. Okay, so this one is more favored compared to this one. So here is the mechanism for intramolecular. Okay, look at here, the base. The mechanism are same from the previous. Okay, so but just the different is we want to cyclize. Okay, so this base, okay, remove this proton, or we call it abstract. So they ambil proton. So what happened? After it takes its hydrogen, so electron move here. Okay, so move here, so carbon become electronegativity. Okay, so this nucleophile will attack this electrophile. Okay, and then pi bond will cleave. Okay, pi bond will cleave to form this one, O minus and H. Okay, so here's there are no lone pair because of this condition. Nucleophile attack this electrophile, so form cyclized product in alkoxide and ion. Okay, so now alkoxide and ion, next step is we want to abstract this proton. Okay, abstract this proton to get aldol product here. Okay, once you get the aldol product, continue with the presence of strong base. Okay, abstract this proton because we want to produce end product of alkene. Okay, so this process we call as aldol reaction, and then you get the intermediate alkoxide anion, and followed by conjugated enolate anion to form the dehydration product. Okay, this one is exercise. Okay, this one is for the synthesis example, uses of Aldol condensation. Okay, you can look here the example.